second part that I mentioned earlier, that would be my second objective, and that was something to do with waves. And so let's begin. Now, in this lesson, I want us to first of all consider the waves of y is equals to tan theta, y is equals to sine theta, and y is equals to cos theta. And I should mention that there is not much we do with the y is equals to tan theta at this level. We'll majorly deal with y is equals to sine theta and y is equals to cos theta. And so since we'll spend a lot of time with the last two, allow me to take some time with the first one, that's y is equals to tan theta. Now, if you're taught to draw a graph for that, you need a table like this one here. Y is equals to tan theta, where theta is angles from 0 to 360, as that table there shows. And again, you will need to have the y is equals to tan theta values. So just put the value of theta to be 0, you get the corresponding value for tan. Again, you put theta to be 15 and on, so that you populate that table as I have shown there. Well, we know that the tan of 90 is not a known number, so we call it positive infinite or undefined number that is positive. The same case with the tan for 270, it's negative and undefined. It's a very big negative number, and so that basically is a table there. Now, if you are plotting that, the graph for y is equals to tan theta will be like that one there on your screen. It is not continuous. Just a few comments about it. The values of tan theta increase from 0 towards 90, and as you approach to 90, they become extremely big and undefined. So there's no way that this red curve will be able to touch this broken line we call the asymptote. Again, also the tan of, if you take your calculator and find the tan of say 90.01, it'll be a negative number, which is very big. So again, this one starts from negative side, goes on to tan of 180 is 0, and continues to, again, the same behavior as we had towards 90, and that just continues. And we can say that the tan for tan theta, the period is still 180, and what else? The amplitude is undefined because of the highest values there, and there's not much we'll say that. And therefore, let's concentrate on y is equals to sine theta and y is equals to cos theta. And so we begin. We need a table of this nature here, the same table we had for the tan, but now we have sine theta. So we have the angles from 0 to 360. My intervals are 15 degrees, so we have 0, 15, 30, 45, 60, all the way up to 360. Again, we'll need the values for y is equals to sine theta, and again y is equals to cos theta, and populate the table as I have done there. Again, I should say there's no skill for that. You just type sine in your calculator. Sine of 0 is equals to that particular value. Sine of 30, sine of 45, sine of 165. Ensure that the intervals are the same. Again, I've rounded my values to 2 decimal places. Please consider that. Again, considering the previous lesson that I just presented, please understand that there are times that sine or cosine or even tan will be negative. So please take care of all of those things. It's assumed that at this level you should be able to do that. So fill the table as I have indicated there, and having done that, let's plot them on the same set of axes. So this is how they should be. Now, the wave for sine theta is normally the blue one there, and the one for cosine is the one that's the next color there. I don't know what color it is. And what should I say? Sine of 0 is 0, whereas the cos of 0 is 1, and just that. I think there's not much I can say there. So all times you're drawing a sine, y is equals to sine something, or y is equals to cos something, they should always look something like this. They can be transformed, and basically this lesson is about transformation of signs. So sine, cosine, and actually sine and cosine waves, but they should always have this let me call it a fundamental appearance. So they should behave or flow as I have indicated there. Maybe I should mention they sometimes look like they are straight lines, like somewhere from here, if you go down at this point, looks like a negative a straight line, and again this other one, and again the other one there. Now, you're not supposed to be tempted to use a ruler to draw a curve. A curve is supposed to be drawn with using free hand, and ensure that it has round turns. Avoid getting V shapes. It should be U shapes, round as they are written there. And so yeah, that's it. So basically this is how your sines and your tan and your cosine waves should look like. Now, we'll be looking at amplitude, and so let me mention something about them at this point: amplitude, period, and phase angle. Now, the amplitude for both of this, the sine and cosine, are indicated there. You see, for the sine is the biggest displacement from the x-axis. How high or even how low does the sine curve go? And again, also, how high or how low does the cosine curve go? How is the highest it can go? In our case, it's just 1. You see that using this scale here, we have 0.1, 0.2 up to 0.9, again 1. So that's the highest it goes. Even if you go below here, the value will still be 1. It is corresponding to -1. So the amplitude is normally the maximum displacement of a wave from the x-axis. In our case, it is 1 for both y is equals to cosine, y is equals to cos x, or y is equals to sin x. Again, the period is the number of degrees it takes for a wave to start repeating itself. If we start with say the sine curve, it starts at 0 here. There's a time it will be 0 again, but it's going on the opposite direction and goes down and then comes back. It looks like from here it will start behaving exactly the same way like it was here. Therefore, we would say that the period for y is equal to sine theta is 360 degrees. That means it takes 360 degrees to start repeating or behaving the same way it behaved in the previous 360 degrees. The same way for cos theta, the wave for cos theta, also the period is the same, 360. You see, it starts from 0, the point 0.1, all right, goes down, it becomes 0 at 90, it goes down up to -1, and it comes up, and it's at this point that it starts to behave the same way it behaved at the beginning. So it looks like it will continue going down and that kind of a thing. So we would say that the wave for y is equals to cos theta, the period is 360. About phase angle, I'll not mention anything at this point, but towards the end of the lesson, I'll say a lot about it and give a summary in that regard. Now, let's look at some more questions, exam questions, and we can tie all of these concepts together in 2 questions. The first question. The first question will have to do with y is equals to sine a in brackets bx plus or minus cos theta and all that. And so this really represents the transformations that I was targeting to tackle in this lesson. They are transformations of some kind of the waves y is equals to sine theta and y is equals to cos theta. And let's begin with the question. We're told to complete the table below by filling the blank spaces, and the table is given there. It's for 2 waves on the same axis. There is a cos x and again 2 cos a half x, and again the angle intervals is 30 going up to 360, and the question is to fill the table. The next thing you're told is that use the scale of 1 centimeter to represent 30 degrees on the horizontal axis and 4 centimeters to represent a unit on the vertical axis. Draw on the grid provided the graph of y is equals to that and y is equals to that. So you just need to populate this and use that data to draw a graph. We'll do that. The next thing, we're told to find the period and amplitude for both curves, and again describe the transformation. Look for period and amplitude of this second one, because the first one is always obvious. And then we use the transformation, describe the transformation that maps the first one onto the second one. And let's tackle that question very fast. We draw the table and put the values. I put the ones that should be filled that were not given or provided for us. I filled them in red, and so you can compare with yours. It's just like in this first case, we have cos of 30 is 0.866, rounded off to 0.82, 2 decimal places, that is. Again, we have cos of 90. Cos of 90 is 0. Cos of 120 is negative 0.5, on and on. And again, for the second curve, we have 2 cos a half of 60. So this will be 2 cos a half of 60, which will be 2 cos a half of 30, because the half of 60 is 30. So a half of that being 30 will be 2 cos of 30. Cos of that is 0.866 times 2, it will be 1.732. Again, for this 90 here, it will be now cos of a half of 90, which is 2 times cos of 45. So cos of 45 is 0.7071. Multiply that by 2 and round off to 2 decimal places, it will be 1.4, and everything else continues that particular way. This will be cos of 120 divided by 2, which is the cos of 60. Yeah, 0.4, which is 0.5 times 2 will be 1. And just fill the values in the table as it's supposed to be done. Now, having done that, you will plot the two graphs on the same axis, and this is how they look like. Please understand that the blue one is the y is equals to cos x. Okay. The second one is y is equals to 2 cos a half x. And that was the first question. The first question was to fill the table and use it to draw two graphs, and we have just done that. Ensure that yours looks like mine. It should be a smooth curve, and this is achievable with a free hand, not with a ruler. Now, for that question, which was y is equals to 2 cos a half x, we were asked to look for period amplitude for the first one, for the y is equals to 2 cos a half x. And so, what will it be? Now, period, we said, is the number of degrees it takes for the graph to start repeating itself. And so, what do you think it will be? I think I should say in this case that just looking at how the graph goes, since this is the one that we're talking about, we're not talking about the y is equals to cos x. We're talking about the y is equals to 2 cos a half x. So since this is the one we're talking about, it continues going down, and what will happen? Maybe it will start going up again. So this looks like a half. From 0 to 360 looks like a half. Okay, it looks like half because this is the highest it is going because it was coming from down. And again, this is the lowest it will go. So it's going now upwards, and so it is just a half of that. Therefore, since this is 0 to 360, it means we need another 360 degrees. Therefore, the period is 720 degrees. At the end of the lesson, I'll show you how it is, but let me mention at this point, 720 is also the same as 360 divided by a half. What was the coefficient? Which was the coefficient of x here? We'll look at that later. Amplitude. What's the amplitude of this? It's the highest displacement from the x-axis, and so the highest it goes is 2. The lowest it goes also is again 2. Okay, yes, it's that one there, this blue line, broken line there. So the highest it goes is 2, and also the lowest it goes is also again at 2. Again, we don't consider positive or negative. Amplitude is displacement, so we don't consider whether it's positive or negative. So in our case it's 2, and that's basically that. Again, I'll mention at the end of the lesson that the amplitude of any graph of cos or sine, it's normally the coefficient of the cos is of something or sine of something. Like in our case, the coefficient of cos a half x. What is just before the cos? That number there is normally the amplitude. Hey, we continue to another thing. The question was also asking about the transformation. So how is the y is equals to cos x, how is it transformed to y is equals to 2 cos a half x? Now, this wording should be exactly as I have written there. So we would say the graph of y is equals to cos x can be mapped on the graph of y is equals to 2 cos a half x degrees by a stretch of scale factor 2 with x-axis invariant, followed by a stretch of scale factor 2 with y-axis invariant. Those are two parts of constituting the transformation. So let me say the stretch of scale factor 2 with x-axis invariant means since x-axis is not changing or invariant, the y-axis is being multiplied by 2. So here the amplitude was 1, it is now being multiplied by 2. Okay, so that's what that first half means. Stretch of scale factor 2. In other words, the amplitude is multiplied by 2. With x-axis invariant, x-axis not changing. So we're only changing the y-axis. If you look at the values that we have here, say we had 0 times 2, sorry, 1, we have the cos of x is equals to 1. Multiplied by 2, you get this. This one you multiply by 2, also you get this. This one multiplied by 2, we are supposed to multiply every figure by 2 to get the corresponding one. That's what that's what we are supposed to pick from here. The second half of the explanation is followed by a stretch of scale factor 2 with y-axis invariant. In other words, this time round, stretching the x-axis but not changing the y-axis. No wonder the period now multiplied by 2. And I think that's clear. This graph here is like everything was multiplied by 2 to get this other one. That means x multiplied by 2, the y multiplied by 2. And I think that's the best I can explain. Let's go to another question. We're told complete and copy and complete the table below for the y is equals to that one there, and y is equals to cos of that one. And again, you're told on the same axis, draw the graphs for both of those curves for the interval from 0 to 360. I think here we were supposed to have had 270, 300, 330, and then 360. Again, use your graph to state the amplitudes or the functions. That is y is equals to 2 sine in brackets x plus 15, and again y is equals to cos in brackets 2x minus 30. And again, also solve the equation that is given there. This is just what we have here, and again the cos in brackets 2x minus 30 is also what you have there. And then you're told just solve the equation where this minus this other one is equals to 0. Let me take you through that. The first thing, we fill the table, and there it is. The interval was from 0 to 360. So fill the values in the table as it should be done. This time round we have the so-called face angle, and so be careful. Let me show you how you get the 0.52. Since x is 0, the first value here will be, we put 0 here, so we have 0 plus 15, which is 15, and then we'll have as 2 of sine of 15. Sine of 15, the value you multiply by 2, you get 0.5 something. I rounded it up to 0.52. The next thing, since here x is 30, we put 30 here. 30 plus 15 is 45. The sine of 45 is 0.7071. Multiply that by 2, you get 1.41 something. So I rounded it off to that. The next part will be cos of, since x is 60, we have 60 plus 15, which is 75. We have now sine of 75 times 2. You get that figure there. And everything continues that particular way. The same thing now for y is equals to cos in brackets 2x minus 30. But this time round, for 0.87, this is what we do. Put x to be 0 here. We're going to get 2 times 0, which is 0. Now, 0 minus 30 is negative 30. So we are looking for the cosine of negative 30. A negative angle means an angle that is measured clockwise from the x-axis. And therefore, negative 30 is the same as 330 degrees. So cos of negative 30 is the same as cos of 330 degrees. In that case, we're going to have the cos of 330, which is 0.87. Remember, with the fourth quadrant, cosine is positive. So no wonder we have positive there. If we go to the next one, we're going to have 2 times 30. That is 2x minus 30. It will be 2 times 30, which is 60, minus 30. The answer is another 30. So cos of 30 is 0.866, which is rounded off to 0.87. The next part, for the third value, we have x is 60. So we have 2 times 60 minus 30, which is 2 times 60 is 120 minus 30 will be 90. Cos of 90 is 0. No wonder we have 0 here. The next figure will be 90. Now that 90 we multiply by 2 to get 180 minus 30, which is 150. Cos of 150, it is negative 0.866. And therefore, all of these figures are populated that particular way. And I should say, interestingly, the y is equals to cos in brackets 2x minus 30. All the figures will just be 0.87, 0.87, 0, negative 0.87, negative 0.87, 0, 0.87, 0.87, 0, and on and on. So that will never change. So maybe at that point I should mention that all times when you are filling figures on trigonometric curves, there is normally a pattern that is always repeating. No wonder we talk about a period, meaning there is a time when the curve starts repeating itself, and therefore whenever that pattern does not seem to appear on your table, you could be wrong. For example, we have 0.52, 1.54, 1.93, 1.93, then now we have again 1.42, 0.52, it becomes negative now, the same thing. So always look out for those patterns. Well, having plotted them, I have done them for you here, and here they are. So this particular color, I don't know what color it is, it's the y is equals to cos in brackets 2x minus 30. The next one is y is equals to 2 sine in brackets x plus 15, and that's that. The idea is just you plot all of the figures here against the x's, and you get the two curves there, and remember they should be smooth, and that's it. Let's go to the next part. I think we're asked about amplitude and period. So let's start with period. And I have drawn kind of a table here. For y is equals to cos 2x minus 30, the period is 180. Is it 180? The question is, how long does that first curve, this one, how long does it take to start repeating itself? It looks like here it's at its topmost, goes down, goes again almost the same place, and looks like somewhere mid of 0 to 30, maybe 15, and again here the same thing also. So it is now 15 degrees after 180. So it is from 15 to 195. That is just 180. So the curve really starts to repeat after 180 degrees. Now, for the next one, the y is equals to 2 sine in brackets x plus 15, the period, what's the period supposed to be? How long does it take for the curve to start repeating itself? Is it 360? It is 360 because if you look at it, let's take the topmost part. It looks like somewhere between 60 and 90. So say I think 75. Yes, exactly 75 there. So it goes down. It looks like between 240 and 270, it is at its lowermost part. And how many degrees are those? If you get, say, this is 255 minus, I think, 75. If you subtract that, and the answer you kind of you multiply by 2, you get the value should be 360. Again, it can also be seen that the first place where it began here, it was at 0 degrees, and the last place it is ending here is at 60, and it looks like this place is exactly like this. In other words, if I continue the curve, it will behave again the way it has just behaved. So the period is 360. The amplitude, what's the amplitude of that one? That's y is equals to cos in brackets 2x minus 30. The amplitude, we say it is the greatest displacement from the x-axis, and so in our case it's just 1. That's it goes, the highest it goes is 1, the lowest it goes is 1 again, and that was illustrated in the previous example. The amplitude for the second graph, that is y is equals to 2 sine in brackets x plus 15, the amplitude is 2. And there's not much I should say there, since it's just the greatest displacement from the x-axis. The highest it goes is 2, the lowest it goes is 2 again. Now let me mention something about phase angle, although I'll still give a summary about this. The phase angle for the first one, y is equals to cos in brackets 2x minus 30, is negative 30 degrees. And the next one, the phase angle is 15. It's peculiar that this negative 30 is the same number we have here. This 15, the same number we have here. When it's negative here, it's negative here also. When it's positive here, it's positive here. So you should already have the conclusion. There's a question we had been asked about we look for the solution for 2 sine in brackets x plus 15 minus cos of 2x minus 30 is equals to 0. So the basic idea of solving this equation graphically means just to take one of the equation on the other side. The student is supposed to realize that these two are the ones that we drew the graph for. We had 2 sine in brackets x plus 15, which is this one. We also had the cos in brackets 2x minus 30, which is this one. So the idea is you should realize that these two are the same we have here. The next thing is you take this one, the second part of it, you take it to the other side and becomes positive. So now we have 2 sine x plus 15 is the same as cos of 2x minus 30. What does that mean? It means the solution for this equation is a point where the first graph meets the second one. Where do they intersect? There's a point they intersect here. And check out your graph. Mine looks like around 57, because it looks like it's after one small square, yet one small square here represents 6 degrees. So this is 150 plus 6 will be 56. So since it's just slightly after that, I estimated it to be 57, and I'd like to know yours. So that's it for that particular session. Let me give now the summary I wanted to say about the phase angle. Now, the phase angle normally describes the degrees with which a wave leads another. Okay? And to illustrate that, I need to give examples. We are given, for example, y is equals to sine in brackets x plus 15. The degrees with which this one leads the curve y is equals to sine x would be the phase angle. And I have plotted it for you there. I don't have the table, but you can just do it on your own and see. So we have the two graphs. We have one, the blue one is y is equals to sine x. The other color there is y is equals to sine in brackets x plus 15. So we would say it's so this color that's close to red, yellow, or something is leading the blue by 15. How? When this was 0, when the blue one was 0, the earlier one was became 0, but it was slightly above there. And I don't know, I can say, if you look at the, let me call it the horizontal displacement of the y is equals to sine x to get y is equals to sine in brackets x plus 15 is a constant 15 degrees. Okay, a constant 15 degrees. And maybe let me use that example again of 0. When y is equals to 0, the y is equals to sine x, the point where that graph was 0, 0 is here. Where do you think the y is equals to sine in brackets x plus 15? When was the x value 0? It must be somewhere next here where it is negative 15 degrees or 15 degrees before the blue one. If you take another one, when the blue was say at 180 is equals to 0, 180 and 0 degrees, it's at this point where I have the cursor. The question would be, when was x value 180 for the other color there, for y is equals to sine in brackets x plus 15? It was 15 degrees before 180. And so that describes it. The phase angle is a degree with which a wave leads another one. And so in our case here, the phase angle is clearly 15. Now it's normally defined by a translation vector. It's a transformation of wave which is normally defined by a translation vector, in which case, for our case, it would be negative 15, 0. So negative 15, 0. It means that if you translate y is equals to sine x by this vector, you will get the other one. And I think that's that. Another example for cosine. If we have y is equals to cos in brackets x minus 30, we have the two curves I've plotted for you there. We have y is equals to cos x again, the blue one, and then we have y is equals to cos in brackets x minus 30. And so what's the phase angle? It's clearly 30. It is as though one curve leads the other one by 30. The y is equals to cos in brackets x minus 30 leads the y is equals to cos x by 30 degrees. Consider this point, for example, the point 90, 0, and again 120, 0. This curve became 120 ahead of the blue by 30 degrees. And that's basically it. The horizontal displacement of the y is equals to cos x to y is equals to cos in brackets x minus 30 is just 30 degrees, in this case positive. So we can say the angle is negative 30. Okay, the angle is negative 30, and basically that. And of course now the translation vector will be now positive 30, and you need to look at that. When you have positive here, this will be positive, the translation vector is negative. When you have negative here, the phase angle is negative also, the translation vector is negative also. And so that's basically it. It's been rather a long lesson, but I want to summarize it. So let's tie these things together, and I want to say one thing. Now, for y is equals to a sine in brackets bx plus or minus theta, or y is equals to a cos in brackets bx plus or minus theta, the amplitude, period, and phase angle can be summarized as indicated here. The amplitude for a is equals to y is equals to a sine in brackets bx plus theta. The amplitude will be a, the coefficient here, the first number that's appearing after the equal sign. The same case also for y is equals to a cos, the same thing there. We are going to have the amplitude is a again. That is the coefficient before the trigonometric ratio, sine, cosine, or even tan. The period is normally given by 360 divided by the coefficient of the x here. X is the angles, say 0, 15, 30, 45, and all that. So the b, that's the coefficient of that value, if you get 360 divided by that, it'll be the period all along the curve text before it repeats itself. The phase angle will always be given by the same sign we had here. We also put it here. So for example, if this was a sine bx plus 40, the phase angle will be plus 40. Remember, we are supposed to put the positive sign, plus. Don't just assume 40 is positive. Put plus 40. Again, the same thing for this. If we have the phase angle is if we have bx plus minus 70, if it was minus 70, then this one will be minus 70. And I believe that brings the concepts well. And there it is, the end of our lesson. It's been about 30 minutes. It's been rather lengthy, but I hope you follow that. Shortly after this lesson, the next lesson after this, I'll be presenting some questions that have to do with the trigonometric equations, which I'll be solving, and that will be the last presentation for me for trigonometry 3. Hope you find it helpful. Thank you.